Hey, Tom.
Hey, Beth.
I have a question for the curator of balloons.
That's not the kind of balloon we collect around here.
What kind of balloons do we collect, Tom?
Well, have I ever told you the story of the sheep, the duck, and the rooster?
No.
You have some time?
I have about 30 minutes. This is STEM in 30. Hi, I'm Beth Wilson. I'm coming to you live from the Stephen F. Udvar-Hazy Center right near Dulles Airport. And today I've got Sunrise Valley School with us. Here at the Udvar-Hazy Center, we display objects that are too big to keep on the National Mall building, such as the SR-71 Blackbird and the Space Shuttle Discovery. Today we're not going to talk about that, though. Today I've got Tom with me, and we're going to talk about balloons.
We sure are.
And we were so lucky that we got a ride in a hot air balloon. So do you all want to take a look at that? Yeah, okay, let's take a look at our ride.
So, Beth, this is the kind of balloon we collect.
This is a balloon.
A real balloon.
Are we ready to take a ride?
Hey, let's go.
Okay. So Tom, do you want to tell me about this rooster, this duck, and this sheep?
I sure do, Beth. They were the first living creatures to fly. The Montgolfier brothers sent them up from the palace at Versailles in September 1783. And you know, people weren't sure if once you got up in the air, if there was air to breathe. So it was a way of making sure that it was okay up there.
And everybody lived?
They all lived. Legend has it that the sheep kicked the duck, but they all survived.
And we've been ballooning ever since.
Since 1783.
Well, I'm so glad we got the sheep, the duck, and the rooster squared away.
And we got to fly.
And we got to fly, right. Now, flying in a balloon is a little different from flying in an airplane, is that correct?
It is. In an airplane, you're flying aerodynamically, and the flow of the air over the wing generates the lift that takes you into the air. But on a balloon, you're flying buoyantly, and that means that somehow you've made the balloon weigh less than the amount of air that it displaces, so it's buoyant and it floats like a cork in water.
Okay, and that's a little difficult to understand if we're talking about it. So we've put together a nice little animation that shows how a balloon works. Do you guys all want to see it? Yeah. Okay, let's take a look.
How do balloons work? Balloons float in the air thanks to buoyancy. Buoyancy creates an upward force away from gravity. We can make a balloon buoyant by making the air inside the balloon weigh less than the air outside the balloon. Since a balloon itself is heavier than air, we must find a way to reduce its weight. One way to achieve that is to heat the air inside the balloon. When air is hot, its molecules are moving more rapidly and taking up more space. So, heating the air inside a balloon will force air out of the balloon. If you force enough air and weight out of the balloon will now weigh less than the air outside the balloon. Now the balloon is buoyant. In a modern hot air balloon, a burner fueled by propane gas heats the air inside the balloon. The pilot needs to keep heating the air with the burners to keep the balloon afloat. When it's time to come down, the pilot allows the temperature inside the balloon to drop. Landing the balloon safely requires the pilot to carefully control the temperature so that the descent is not too fast.
Well, I think that's a pretty good explanation. However, this is 7:30. So we can't just tell you how something works. We have to show you how something works.
Of course.
And to do that, I'm going to ask Marty and his helpers to show us how a hot air balloon works. Marty?
Thanks, Beth. I've got some friends here helping me with our hot air balloon. I put this together last week. It's made out of tissue paper and glue sticks. And there's some cardboard and a few staples underneath it. But basically, it's tissue paper and glue stick. And what we're trying to do, we've got a heat gun down here. Guys, lower it down just a little bit. We've got a heat gun that's heating the air going inside, forcing some of that cooler air out from the bottom. And what we're hoping to have happen here in a minute is this will get buoyant, lighter than air, and will take off. If you're interested in making a hot air balloon like this, the lesson plans are actually on the STEM in 30 website. And so you can go in there and there's a how-to video on how to create this hot air balloon, and hopefully it will fly here in a second. Guys, why don't you go ahead and let go of it? Go ahead and let go. Oh, I think this is going to be great. You guys ready? Here we go. There it goes. There you go, Beth. It took off. We're going to keep flying this, so we'll send it back over to you.
It looks like they're having a lot of fun.
It looks like.
I think we have some questions. So are we ready for some questions?
You bet.
Okay, well, let's start with a video question.
Hi, my name is Rishi. Hi, my name is Jordan, and we want to know what material hot air balloons are made out of.
So, Tom, what are hot air balloons made out of?
Well, most modern hot air balloons, Beth, are made out of ripstop nylon. If you have a windbreaker, it's probably made out of the same thing. Pretty tough, not very heavy.
Okay, and do we have an online question? How do you steer a balloon? Do you have a steering wheel or?
No, you really can't steer a balloon. A balloon's going to go where the wind moves it. So the only thing you can do when you're up there is to go up and down looking for a current of air that moves in the direction you want to go.
So you're completely relying on the weather is what you're saying?
You're inside the wind.
Okay, and we have a question from the audience.
How do you make such a stretchy, like, long nylon that's like so big?
Does the nylon stretch, or is it a stretchy material to make the balloon inflate?
No, it's not very stretchy. It just inflates when you fill it full of hot air. It doesn't stretch at all.
Okay, so it's not stretchy, not like a latex balloon.
Nope.
Not
Right.
like the toy balloon. I think we have another question.
Is the nylon flammable? And if it is, how do you make sure it doesn't burst into flames?
How do you keep the nylon from bursting into flames?
Very carefully. You have to be careful when you're burning the propane to keep track of the temperature inside the balloon. because it will burn. You're right. You have to be real careful.
Is there a thermometer inside the balloons?
There is. There's a temperature gauge up on top where it's hottest, so that the pilot always knows.
How hot it is?
Yep.
Okay, what's your question?
What's the ratio of weight of a person inside the balloon to hot air?
So what's the ratio between weight and hot air? How much hot air do you need to get a person off the ground?
Well, that depends on how much the balloon weighs with the person in it. You have to get rid of enough weight of air to make the whole thing lighter than the amount of air that it displaces.
Okay, so we don't just collect like the gondolas and the balloons. We
Right.
also collect a lot of other things about ballooning. And you just got a very important collection in. So do you want to tell us a little bit about that?
We did. It's called the Evelyn Way Kindle Balloon and Early Aviation Collection. And when balloons were invented in the 1780s, people were just fascinated by them. And they made all kinds of little gizmos and gadgets, little boxes and needle cases and so on, with balloons on them because people were so excited about balloons. And the Kindle collection has about 1,000 things like that, a really big collection.
Now, we have Greta and Vanessa who are doing some work on the Kindle collection. They're going to show us one very important piece.
Great.
So this is one of the many paintings that are in the collection, which we're very excited to have because a lot of people don't think of paintings and art when they think about the National Air and Space Museum. So this is a painting done by a French artist named Lorimer in 1784, and it is showing the ascension of a gas balloon. The ascension happened also in 1784 in France.
One of the exciting things about this painting is that the artist chose to depict the barrels in which the chemistry was mixed to allow the balloon to fly. It was essentially sulfuric acid with metal filings like iron or zinc. This was a very scary and somewhat flammable reaction, but it allowed the balloon to fill up with enough hydrogen to take off. These are just a few of the many varied artifacts that we have here in the Kindle collection.
Now, Tom, we have a lot more artifacts in the Kindle collection. My personal favorite being the fan.
Mine too.
And we didn't have enough time to show all of them. But if you go to our website, we will have more video of some of the other objects that are in the Kindle collection. And Greta and Vanessa will tell us a little more about what they do. But right now, Tom, it's time for our game show.
Wow.
Marty?
Hello and welcome to Stim It to Win It. I've got my contestants here. I've got Josie, Carter, and Mika, and this is the game that tests your wits as well as your speed. Are you guys ready?
Yes.
All right, your first question. Take a look at the monitor and tell me, who is this? All right, Carter, who is that?
Abe Lincoln.
That is Abraham Lincoln, exactly correct. Are you guys ready for the second question? All right, there was an armed conflict going on while Abraham Lincoln was president. What was that?
Civil War.
That was the Civil War, correct. And now for the last question. We've saved the hardest for the last. We know that Abraham Lincoln had an army. Did Abraham Lincoln have an Air Force?
No.
She says no, that is incorrect. Anybody else want to guess?
Yes.
He did have an Air Force. And to learn more about that, let's go back over to Beth and Tom.
Surprisingly enough, Abraham Lincoln did have an Air Force, but it wasn't airplanes, was it?
No, it wasn't. It was balloons, Beth.
Okay, and let's take a look at who suggested the Air Force for Lincoln. Who is this gentleman?
That is Thaddeus Sobieski Constantine Lowe. He was a New England man who was a balloonist, traveled the country making flights, selling tickets and that kind of thing. And when the Civil War broke out, he wanted to contribute. And so he wrote to the Secretary of the Smithsonian, came to Washington, and the Secretary introduced him to Lincoln.
And we have this letter in our collection. What is this letter about?
Well, Lowe had a tough time convincing the Army that the balloons were a good idea. And so Lincoln actually wrote that letter in our collection, a little note, telling General Scott to pay attention to what Lowe wanted to do.
Now let's take a look at the National Mall the way it was during the Civil War. You want to tell us what's important about this map that we have here?
Well, this picture, you're standing about where the Capitol is, and you can see the incomplete Washington Monument down there, and between them, the Smithsonian Castle. And about halfway between where you are here and the castle is where the National Air and Space Museum stands today. And that's where Lowe made his first demonstration flight to convince the president and the Army what you could see if you were 500 or 1,000 feet in the air.
Okay, and he didn't fill these balloons with hot air, right? So we have a photo of how he filled them. So if we take a look at that, can you tell us a little bit about what's going on this photo?
Sure. When he was in Washington, he would actually fill up the balloons with city gas, the gas that they lit the city streets with and so on. But out in the battlefield, there weren't any gas plants. So he had to generate his own hydrogen. And in those two boxes that you see on wagon beds, you mix sulfuric acid and iron filings and generate the hydrogen to fill the balloon.
Now, so President Lincoln did actually have an Air Force, but not the kind of Air Force we have today.
Well, he did, and President Davis, Jefferson Davis, of the Confederacy, had some balloons too. But you're right, not the kind we have today.
Okay, we have some questions now. We're going to start with a video question.
Hi, my name is Chess, and I want to know, how hot does the inside of a hot air balloon get?
How hot does the inside of a hot air balloon get?
Well, it has to get hot enough to drive enough air out so that the balloon will fly, and yet it can't get too hot or the fabric will catch on fire. So it's a fine balance. Again, the pilot has an instrument in the top of the balloon to tell him how hot it is, so it won't get too hot.
Okay, and we have some questions. So let's start with our audience question here.
How far could a hot air balloon go?
How far?
Yeah.
Well, hot air balloons are kind of limited to the amount of propane you can carry. You have to have that to keep the fire, to keep the balloon up and moving. Gas balloons can fly a lot farther than hot air balloons can.
We have another question?
Did the air balloons back in the day have the same design as they do now?
Did hot air balloons, did the Montgolfier brothers' hot air balloons look like our hot air balloons today?
Well, they kind of looked like it, but the technology was different. They used an open flame. They inflated the balloon over an open flame on the ground, and they carried a little thing to carry fire in it when they were in the air to keep themselves up. So they looked kind of the way balloons do today, but the technology was real different.
Now, we've talked about hot air balloons, but you mentioned that Abraham Lincoln's Air Force had gas balloons.
Indeed.
And gas balloons and hot air balloons are a little different.
They are.
And we have another animation showing us what a gas balloon, how that works. So let's take a look.
How do gas-filled balloons work? The other way to make a balloon buoyant is to fill it with gas that is lighter than air. Hydrogen and helium are two gases that are lighter than air. Most balloonists in the United States use helium. Although the helium is slightly heavier than hydrogen, it is non-flammable. Once a balloon is filled with enough helium and the combined weight of the balloon and gas becomes lighter than air, the balloon will float. In order to make the balloon rise, the pilot will drop sandbags, reducing the total weight of the balloon. In order to descend, the pilot pulls a rope to open a valve on top of the balloon. This allows some of the gas to escape, making the balloon heavier and causing it to lose altitude.
Okay, so there's a difference between gas balloons and hot air balloons.
Indeed.
And we are so fortunate that we actually have this great gas balloon in the museum.
Isn't that neat?
Yeah, it's great, isn't it? And to tell us a little bit more about it is Marty, and he's going to introduce us to Kurt.
Great.
Thanks, Beth. I'd like to introduce Kurt Westergaard. He's the president of Digital Design and Image Services. And Kurt, you brought in a really great balloon here today, but it's kind of funny looking. Can you tell us a little bit about it?
Well, it might be funny looking, but we call that an aerostat. For Latin, aero, it's in the air, and stat, meaning it's standing. You can see the tether holding it to the ground, which is real important. And This particular shape actually gets its lift from that net hanging on the back. It points it toward the wind.
So this balloon is not only floating but also creating lift?
That's correct. It's got two ways of lifting up. The helium, as just described, is lifting it. That's what the big bag is for. And the belly of it is getting some natural lift, like a kite gets lift when it's on a windy day.
Now, I see up here you've got an airplane mounted underneath the balloon. What's that for?
Well, that's a drone, or what they call an unmanned aerial vehicle, and we're trying to test its ability to not lose a connection or not to crash, basically. And by holding it up there on that cradle, which you see, it's pinned on there, we can test it against jamming or losing batteries or other ways that they might fail.
Now, looking at the balloon, there's a big orange net at the back of it, but it looks like you caught an airplane in it. What happened?
Yes, we are trying to experiment with the idea that a balloon can catch a glider, and that means the glider can fly right into it, hook on, drape down, and then rest for a while, meaning its batteries get charged up, its data gets Bluetoothed back to a signal. So we're still on the experimental stage of that, but we think it's going to be a pretty interesting thing to not come down to the ground and stay up aloft for much longer. This, of course, lets people do missions, like if you wanted to fly out to an island that's 10 miles away, but you only have batteries to get about 5 miles, you can get a lot longer and further just by gliding down from a starting point that's 1,000 feet in the air.
Now, on the side of your trailer here, you've got these pictures of the buildings, and you guys do something else with the balloons as well, right?
Right. Our core work, our core activity as a landscape architect is to help architects plan skyscrapers. And what you see on the side of the building there is that a number of proposed skyscrapers, the World Trade Center, for example, 1,400 feet. So we lift the balloon right up where the skyscraper is going to be in the future, and we get it right to the right altitude, meaning the penthouse or a particular window, and then get a 360-degree photo of that using a 9-eye camera.
Now, last night you launched the balloon and had an opportunity to take some pictures here of the Udvar Hazy Center, right?
Yes, that was terrific. We really got some good shots. Ryan took those pictures and glued them all together into a spherical panorama, which we've put together and put online.
And can we take a look at some of those pictures?
Sure. Michelle, maybe you could take a look and steer around that.
Now, this balloon and the equipment with it doesn't look like something that you can just go to the store and buy.
No, fortunately for us, since we like inventing things and building things, we really needed to invent every little piece of this together, from this big funny box with doors on the top to this winch you see on the side here, which has a bicycle crank to bring the balloon in. So everything needs to be designed and built and then tested and then retested. And that's an exciting process to do on its own. And that invention process is steered by and really encouraged by the art of drawing things down, sharing them with people, refining them. So I'm encouraging all of the STEM students here now is to keep a journal, draw every day, write every day, find problems and try to solve them through that technique. And it's both rewarding on its own and it leads to a number of inventions.
Awesome. Well, Kurt, thank you so much for bringing the balloon in and joining us today. Let's send it back over to Beth and Tom.
Okay, so we have looked at Kurt's very cool balloon. And the nice thing about gas balloons is they can go a little higher.
They can.
And you were very kind to take me and show me the capsule from one of the highest gas balloons ever launched. And do you want to take a look at that?
You bet.
Okay, let's take a look. Tom, we're in front of the Red Bull Stratus capsule. Do you want to tell me a little bit about why we have this here at the museum?
Sure. At one point, this capsule set 2 world altitude records, the highest a balloon had ever flown and the highest parachute jump. In October of 2012, Felix Baumgartner jumped with his parachute from this gondola from 128,000 feet. So world altitude balloon, world altitude parachute.
Now this is a capsule and not a basket like we normally see on hot air balloons. So why do we have a capsule and not like a basket?
Well, the higher you go, the lower the pressure. And when you're in an open basket, obviously, you're in that low pressure. To make things a little easier and a little safer, this is a pressurized gondola. So he rides all the way up into the stratosphere pressurized. And it's only when he opens the door and gets out on the front step and jumps that his pressure suit kicks in, and then that's what protects him.
Now, why did they use a balloon and not, say, an airplane?
Well, for most of the history of flight, balloons were always able to fly higher than airplanes, until the space age, really. And it's because the physics are different. When you get that high, there isn't enough air flowing over the wings of an airplane to generate lift, or enough air on the control surfaces to be able to control it. But a balloon, the physics of ballooning means you can fly all the way up to the roof of the sky.
How high can you go in a balloon?
Much higher than 128,000 feet where this one flew.
So if he didn't have this balloon, he would have needed a rocket, is what you're saying.
He would have.
Thank you so much, Tom. Shall we take a video question?
You bet.
Let's take a video question.
Hi, my name is Sarah.
Hi, my name is Caprice.
And our question is, how long can a hot air balloon stay up in the air?
Well, basically, the answer is as long as there's propane. They burn propane to make the heat to keep the balloon in the air, and when you run out of propane, you have to come down.
All right, let's take an online question. What is the largest hot air balloon ever recorded?
Well, actually, the largest hot air balloon, one of them, was flown right at the beginning of the air age in 1784. The Montgolfier brothers, who invented the hot air balloon, built one that actually carried 16 people into the air.
That is all the time we have for today. I'd like to thank the Gertrude E. Skelly Foundation, our Sunrise Valley students who came in today. I'd also like to thank Friendship Hot Air Balloons, who took us on this wonderful ride, and Kurt and his crew for bringing in their really cool gas balloon. I'd also like to thank Marty and, of course, you, Tom.
Thank you, Beth.
And I hope to see you all back here on April 8th for our next 10 and 30, where we'll be looking at World War I.